Okay, let's move on to section 4.4. We have a couple more congruence theorems for you to learn about. So for my first example, again, I'm going to start off the same way as we did there in section 3. Let's follow a set of directions and see how many different triangles we can produce here. So we want to draw a triangle ABC where segment AB has a length of 7 centimeters. The measure of angle A is 60 degrees and the measure of angle B is 50 degrees. So we'll again start with a line. And as I did before, I'm going to change that to something else. Let's put a point on the segment. And then let's measure and make sure I've got this set right. Okay, well, 8's too much. That was supposed to be 7. So I need to bring it back a little bit. There we go. Okay, so I've got one side of my triangle. The next piece of information, the measure of angle A is supposed to be 60 degrees. Well, conveniently, right here I have point A, so I know that's the vertex of my angle. So I want to draw Sure, I can use this as one side. I can use this as my vertex. And I want to draw that so it's 60 degrees. Isn't that what it said? Yeah, 60 degrees. Now in this case, I'm sorry, I neglected to point this out to you last time. When you're using GeoGebra, they give you the option of which way you want to go. So I'm hoping from B, anchored at point A, I want to rotate around in a clockwise direction, and that's wrong. Let's try it again. There we go. That's going up. Now you'll notice here the length of segment AB is the one and only side length that we have here. I really don't know how far to go. So I am going to draw this as a ray from point A headed in that direction. So this is, I'm going to pull this out a little bit here. Here's my angle A, that's 60 degrees. I don't know how far out that's going to go. And then the third piece of information, measure of angle B is 50 degrees. All right, so I need angle with given size. Vertex at B. This time I want this 50 degrees. And again, it went the wrong way. So that's headed in that direction. Goodness only knows how far. So then I draw this ray at 50 degrees. So it goes through here. Lo and behold, there's only one point of intersection. There's only one possible location. If segment AB is 7 centimeters long, angle A is 60 degrees, angle B, sorry, pull that out a little bit there, is 50 degrees. By taking those two angles, extending those out until I find a point of intersection, there's only one point of intersection. That's a demonstration of why the angle side angle congruence theorem is true. If you have a triangle where one side is 7 and this angle is 60 and this angle is 50, then your triangle is going to be congruent to my triangle. There's only one way to draw it. Okay, well, we could do a reflection. I put point A over here. You could put point B over here. You could put point A up there. It'd be a rotation. There's some rigid motion that'll take your triangle, no matter how you constructed it, no matter how you drew it. So it would map it onto my triangle. They have to be perfectly congruent. So here's our angle side angle congruence there. Two angles in one triangle are congruent to two angles in another triangle. And the included side, okay, so now that's, let me put this on pause here a little bit. That's a sticking point for some people. This is the included side. Between angle M and angle N, the included side is segment MN. Between angle S and angle T, the included side is segment ST. Okay, so you're going to be given two angles and the included side. So again, that's why we put the S in between the two A's, because that side is the included side between the two angles. And again, just as you see here. Let's take a look. Based on the markings, are angle JKL and angle MNO congruent? So again, we take a look at angle J, that's got the one arc. Angle M has one arc. Those are congruent. Take a look at angle K, two arcs. Angle N, two arcs. Those are congruent. And then the included side between angle J and angle K is segment JK. The included side between angle M and angle N is segment MN. Those two triangles have to be congruent by the angle side angle congruence theorem. And again, it's a big long name. You can do some abbreviations there. Don't forget the congruence. I will drill that into your heads as we go along here. And then for part B is triangle JKL congruent to triangle PQR. Well, again, J's got the one arc, P's got the one arc, K's got two, Q has two. Yeah, we've got a problem here. Now, this may seem like it's a yes or no question, but actually there's a third option. Those two triangles might be congruent. At this point, we don't know, okay? The issue here is that the side, segment QR, that's marked as congruent to segment JK, in this triangle is not the included side, okay? So for triangle JKL, the markings that's what we're expecting, two angles in the included side. For triangle PQR, we have two angles and the non-included side. So that's what angle side. Okay. If these two are not the same, you can't say that they are congruent. Again, that's not the same thing as saying no, they're not. We need more information. Okay. As we're going through this, I'm not sure if we've brought this up often enough. There is no such thing as the it looks like it theorem. Well, I mean, you compare those two triangles there for JKL and PQR. They certainly look like they're congruent, don't they? We have the side-side-side congruence theorem, the side-angle-side congruence theorem. Now we've added the angle-side-angle congruence theorem. There's no such thing as the it looks like it theorem. Don't ever try and use that. I will take off bonus points. Why are those two triangles congruent? Well, they look like it. All right, let's try another one. Triangle ABC, where segment AB is 7 centimeters, the measure of angle A is 60, and the measure of angle C is 40 degrees. Well, okay, let's start with a new picture here. Let's draw a line. That's not the location of point B. Oh, that was a good guess. Okay, so segment AB 7 centimeters, the measure of angle A is 60 degrees. So again, put in a nice spray. Don't know how far out to go here. So there's my 60-degree angle, and then the measure of angle C. Measure of angle C is 40 degrees. Here's point A. Here's point B. Point C is going to be up here, but at this point in time, I don't know where. I know it's going to be somewhere on this ray going out, but they didn't tell us the length of segment AC, so I'm not exactly sure where to put it. Don't fear. And now to your rescue comes the triangle angle sum theorem. You're given two of the angles of the triangle. I know the location of point B. What's the measure of angle B? That's right. If we got 60 here and 40, that's a sum of 100. The three angles of a triangle have to have a sum of 180 degrees. So by using that other theorem, I can figure out that angle B has to be 80 degrees. So there's my 80-degree angle. Move this over, move this over. Oh, that's much bigger than I thought. It did say 40, right? Good, because it turned out to be 40. how many different triangles can you draw that have those measurements? Again, there's only one point of intersection. The construction of this turns out to be pretty much the same as the construction for the angle side angle congruence theorem. It's just that we're going to ignore it. Okay, but now here, please pay attention to this. I'm given this side, this angle, and this angle. So this side here is not the included side. The included side between angle A and angle C should be segment AC. This is the non-included side, but it worked anyway. Here's our fourth way to prove that two triangles are congruent. It's the angle-angle side congruence theorem. The two angles in a non-included side in one triangle are congruent to two angles in a non-included side in the other triangle, then the two triangles are congruent. Okay, so it doesn't matter if the way the picture is marked there is angle side angle or if it's angle angle side. Both of these methods are valid congruence theorems. But keep in mind, if you're trying to prove that they're congruent, you've got to use the same theorem for both triangles. Okay? All right, so let's take a look at a proof. Absolutely positively vital that you copy the picture. Geometry is very visual. I have mentioned that to you before. What we're going to do here is mark the picture, and that's going to help us distinguish between the four different congruence theorems that we have. Okay, so let's try this one as a two-column proof. It's been a while since we did proofs. So on the left, we're going to come up with statements that we absolutely know are true, and we're going to back up every single one of those statements with a reason. We're going to go through a logical sequence here using deductive reasoning and hopefully lead us to our final conclusion that yes, those two triangles are congruent. Now, first of all, let's bring the anxiety down a little bit here. They're not going to say, hey, do this proof, and it's a trick question. All of these things where they're going to give you a proof to do, they can be done. So you don't have to worry about that. Oh my goodness, where do we start? It's always a good idea to start with the given information. Angle P is congruent to angle S, given. There's another one. That segment TQ is congruent to segment RQ, given. Well, that was pretty easy. Now, how well have you been paying attention? We have several triangle congruence theorems. We have the side-side-side congruence theorem, the side-angle-side congruence theorem. Today we've added the angle-side-angle congruence theorem and the angle-angle-side congruence theorem. How many pairs of corresponding parts do we need in order to prove the two triangles are congruent? If you said anything other than 3, then you're not paying attention closely enough. But again, this is a key thing. It's not only 3 pairs of corresponding parts. It has to be the right ones. So with the given, we've got two pairs of corresponding parts that are congruent. We need a third somewhere that we need to find on our own. And hopefully you did already notice, because of the interesting arrangement of those two triangles, yes, all the way back in chapter 1, vertical angles are still congruent. So let's name those two angles. Please don't say angle Q is congruent to angle Q. That is inaccurate. It is not specific enough. Angle Q, huh? Do you mean this angle Q? Or, wait a minute, maybe you mean this angle Q. We can say angle S and angle P because there's only one angle that uses S as the vertex. For point Q, there's a whole bunch of angles that use Q as their vertex. We need to use 3 letters to name it. So we could say that angle RQS is congruent to angle, now we got to be careful here, is RQS congruent to PQT, or should it be TQP? In other words, I've put point R first, naming this angle. Point R corresponds with what? Now, if you're not sure, they gave you a hint with our congruence statement here. R is the second point that's named. You have to go in corresponding order. T is the second point that's named, so R corresponds with T. So I have to call this angle TQP. The reason is the vertical angles theorem. Did you spell vertical correctly? So we have 3 pairs of corresponding parts in these two triangles that are congruent. Is that enough? Yeah. Is it the right kind of information to say that the two triangles are congruent? Basically, at this point in time, we want to make sure that this is not angle side side. Well, it's not angle side side because we have 2 angles and 1 side. So yes, it is enough information. Step 4, we can say that triangle, use this, QRS is congruent to triangle QTP. And of our 4 triangle congruence theorems, which one is this? Okay, the one pair of corresponding sides is not the included side, so this is the angle side congruence theorem. And again, I have previously warned you, if you just put down AAS on any quiz or any test that I give you, I'm taking off half point. That may be all that you've been required to do with the online homework, but I have higher standards. All right, so to try and summarize here, again, under the category of valid triangle congruence theorems, we have side, side, side. We have side, angle, side. Those from both from section 3. Today we've added angle, side, angle, and angle, angle, side. You cannot use angle, angle, angle. Well, wait a minute. If we use side, 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 what's wrong with angle, angle, angle? If I give you directions, I give you the measurements. This angle is 50 and this one is 60. Well, then, of course, we can figure out what that third angle would be. Your triangle is going to look like mine, but is it going to be congruent? If you're given all three angle measures in one triangle, the same as all three angle measures in another triangle, you don't know anything about the sizes. You don't know the side lengths. There's no way to say, again, remember, if they're congruent, they have to have the same exact shape and the same exact size. And if you don't know anything about segment lengths, we can't prove that those two triangles are congruent. And again, we've talked about a little bit here, angle side side. No, I'm not going to write it as angle side side, and neither should you. You try and write angle side side on a quiz or a test, there should be bells and whistles going off in the back of your head saying, wait a minute, I shouldn't be writing that down on my papers. Okay? Now, the reason it doesn't work is not just because it spells something vulgar in English. There's a long technical explanation, and you will get to that when you get to pre-calculus. All right, let's wrap this up and do one more proof. Get some confidence going here. How about a paragraph proof this time? Hopefully you're paying attention here with all of these. The given information isn't usually going to say something about the measure of this and the measure of that. We're going to try and keep it as short as possible here. Everything's congruent parts, congruent triangles. So make sure that you're using the congruent symbol. Okay, in the given, we've got a pair of congruent angles. We have a pair of congruent sides. Almost that same um, arrangement that we saw earlier. We could say that angle AXD is congruent to angle. Now again, I've started, this one's pretty simple. If I start with the right angle and then go to X, here I have to start with the right angle. So this is CXB. And again, if I mark that on the picture, then we can say that triangle AXD is congruent to triangle CXB. And again, based on the markings, get two pairs of angles. So this can't be side, side, side. Two pairs of angles. It can't be side, angle, side. Okay, so there we have, wait a minute. The prove statement here doesn't just say that the two triangles are congruent. We're supposed to somehow prove that segment AX is congruent to segment CX. Yeah, how much do you remember? In section 3, we not only talked about the side-side-side congruence theorem and the side-angle-side congruence theorem, but we talked about another one. I can say that segment AX is congruent to segment CX. There's no theorem here that says, oh, adjacent sides that share a vertex of, no, no, no. Did you practice saying it real fast? Corresponding parts of congruent triangles are congruent. Here I've said that the two triangles are congruent. So then I can name any pair of corresponding parts of those congruent triangles and say they also have to be congruent. Could have just as easily proven that angle B is congruent to angle D. Okay? One of the key things, I cannot overemphasize this, you cannot use CPCTC until after you have proven that you have congruent triangles. You can't start with CPCTC. Okay? This only comes after a statement saying that this triangle is congruent to that triangle. All right, well, that pretty much wraps it up. And again, hopefully you've got this in your notes. And go to the Realize website and give section 4 a shot. And again, we'll go through any questions that you may have next time.